You've been driving your Ford for months, maybe years, and you think you know exactly what it's doing under the hood. You know how to sync your phone, you know how to operate the cruise control, and you assume that if the engine is running smoothly, everything is fine. But I am here to tell you, after 15 years on the shop floor tearing down blown EcoBoost engines and replacing scorched transmissions, that your Ford is quietly working against itself. Right now, straight from the factory. Your vehicle is running hidden settings that are actively accelerating wear on your powertrain, shortening the lifespan of your oil, and setting you up for a massive, multi-thousand-dollar repair bill down the line. The manufacturer calls these features conveniences or efficiency measures. In the service bay, we call them job security. Let's look at the first hidden culprit: your automatic engine auto start, stop default behavior. You think you're saving a few pennies at a red light, but what Ford doesn't tell you is the catastrophic toll this takes on your engine's internal components. When your engine shuts off, the oil pump stops turning and the vital hydrodynamic film, the microscopic cushion of oil that prevents metal from metal contact, bleeds away from your crankshaft journals. Every single time that engine fires back up, those heavy components grind together for a fraction of a second before oil pressure can reestablish. I have inspected engine bearings from Fords with under 50,000 miles that looked like they had been scrubbed with coarse sandpaper, all because of this single factory setting. The fix is remarkably simple, yet nobody does it. You need to access your vehicle settings or utilize a simple hardware module to permanently invert that switch, disabling the system by default so your engine stays lubricated when you need it most. Then there is the Eco Mode default calibration that many drivers leave active, thinking they are being environmentally conscious. What this setting actually does is reprogram your transmission control module to upshift as early as humanly possible, dragging the engine's RPMs down into a zone known as low-speed pre-ignition territory. In plain terms, it forces your engine to lug under heavy load in a high gear, creating immense pressure inside the combustion chambers that can literally crack a piston skirt right in half. I've pulled apart blocks where the piston looked like a dropped coffee mug, completely shattered, because the driver let the factory eco-tuning smother the powertrain. To protect your investment, you must manually shift out of this mode or adjust your drive settings to standard or sport, allowing the transmission to hold gears long enough to keep the engine inside its safe, optimal operating RPM range. Have you ever looked at your dashboard and trusted the digital oil life monitor implicitly? This is perhaps the most dangerous misconception on the road today. Ford's intelligent oil life algorithm calculates oil degradation based on ideal operating parameters, often stretching oil change intervals out to 10,000 miles or more to lower the advertised cost of ownership. But out here in the real world, short commutes and stop-and-go traffic cause severe fuel dilution, where raw gasoline seeps past the piston rings and thins out your motor oil until it has the consistency of water. I have drained oil from late-model Fords that smelled like a lawnmower gas tank, completely stripped of its ability to protect the moving parts. The solution isn't buried in a digital menu, it's a mental overwrite. Ignore the factory monitor completely, wipe that 10,000-mile recommendation from your memory, and dump that oil every 5,000 miles max if you want your turbochargers to survive. Let's talk about another hidden vulnerability: the factory electronic parking brake, auto-engage settings on modern Ford trucks and SUVs. Many owners never touch the parking brake, relying entirely on the transmission's parking pawl, a tiny piece of metal about the size of your thumb, to hold a 5,000-pound vehicle on an incline. When you slot the shifter into park without securing the brakes first, the entire weight of the vehicle slams against that mechanical pawl, binding the linkage and wearing down the internal components of your transmission. Over time, this constant stress can cause the pawl to shear off completely, sending your vehicle rolling backward down a hill. I have seen the aftermath of these failures, and it is never pretty. The fix is a habit adjustment backed by technology. Go into your vehicle assist settings, enable auto parking brake engagement, or manually set the brake before you let your foot off the main brake pedal, transferring the load to the heavy-duty brake rotors where it belongs. We also need to address the smart charging alternator profile that comes pre-programmed into your Ford's body control module. To eke out a fraction of a mile per gallon, the vehicle's computer tells the alternator to stop charging the battery during normal driving, allowing the battery voltage to drop dangerously low before it kicks back in. This constant deep cycling cooks your battery from the inside out, shortens its lifespan to less than 2 years, and places an immense electrical strain on your sensitive modules. Drivers often find themselves stranded with a dead cell out of nowhere, blaming the battery manufacturer when the real culprit is the factory software logic. To bypass this, a technician can recalculate your battery management system profile, or you can regularly use an external smart charger to keep the cells topped off and prevent the system from starving your electrical grid. Consider your smart all-wheel drive system's power takeoff unit, or PTU, which Ford famously labels as containing a lifetime fluid that never needs servicing. In the shop, we know lifetime fluid simply means the fluid will last until the component fails and destroys itself. Because the PTU sits directly next to the blistering hot exhaust system, the meager quart of gear oil inside it cooks continuously, transforming into a thick, tar-like sludge that can no longer lubricate the high-speed gears. When that sludge fails, the gears strip themselves bare, often locking up the drivetrain while you are traveling at highway speeds. I have personally replaced dozens of cracked PTU housings that were bone dry inside, burned up by a factory maintenance schedule that ignores reality. The solution here is defying the factory manual. Locate a specialized shop to flush that PTU fluid every 30,000 miles, preventing the hidden rot before it costs you a whole new drivetrain. Even your climate control system has a hidden setting that is actively breeding trouble right under your nose. The factory default logic keeps the air conditioning evaporator housing sealed tightly when you turn off the vehicle, trapping condensation inside a dark, warm environment behind your dashboard. This trapped moisture creates the perfect breeding ground for mold and bacteria, resulting in that foul, sour gym sock smell you get every time you start the car in the summer. Beyond the awful odor, you are actively breathing in those spores every single day you drive. Most owners don't realize that Ford built a hidden software feature called Afterblow into the vehicle's computer, which runs the climate blower motor automatically after the car is turned off to dry out the housing. It is turned off from the factory, but any certified technician with a diagnostic tool can activate it for you, drying out the system completely and saving your lungs and your cabin comfort the deeper you dig into these factory configurations. The more you realize how much capability and protection Ford has locked away behind standard menus or left completely unsaid in the dealership showroom. Your vehicle is packed with sophisticated electronic safeguards and mechanical optimization tools that you have already paid for, yet they are sitting completely dormant while your hardware takes a beating under default setting. We have only scratched the surface of how these factory omissions alter the daily reality of owning and preserving your vehicle. There are still several critical, hidden configurations and mechanical blind spots buried even deeper within your Ford systems that we need to expose before you turn the key again. We just uncovered how the factory auto start-stop default silently scrubs your engine bearings raw every time you pause at a traffic light. That is a slow, systemic wear process that takes years to fully manifest. But there is a second, far more insidious factory configuration buried inside your Ford's computer architecture that makes the start-stop issue look like minor cosmetic wear. If you are driving a modern EcoBoost-powered Ford, whether it's a packed F-150 on a job site, an Explorer hauling your family, or an Escape handling your daily commute, there is a hidden software strategy running right now that represents the single greatest threat to your engine's survival. It is the factory-programmed transmission shift scheduling logic, coupled with low-speed pre-ignition mitigation parameters. And it is actively setting up your cylinders for a sudden, catastrophic detonation event that will blow a hole straight through your engine block. To understand the sheer destructive scale of this setting, we have to look at the mechanical intersection of turbocharging and modern direct injection fuel systems. Ford engineered these downsized turbocharged engines to deliver massive amounts of torque at incredibly low engine speeds. To hit those aggressive fuel economy targets mandated by federal regulations, the factory powertrain control module is programmed to aggressively hunt for the highest gear possible, keeping your engine lugging along at 1200 to 1500 RPMs. When you step on the gas pedal to accelerate or climb a mild grade without forcing a downshift, the turbocharger instantly spools up, stuffing massive amounts of compressed air into the cylinders while the engine is barely turning over. In the automotive engineering world, this high-load, low RPM condition is the exact breeding ground for a phenomenon called low-speed preignition, or LSPI. Here is exactly what happens inside the combustion chamber during an LSPI event, and why the factory programming fails to protect you. Under normal operation, your spark plug fires at a precise millisecond, creating a controlled flame front that pushes the piston down smoothly. But when the engine is lugging at low RPM under high boost, the pressures and temperatures inside that cylinder skyrocket to extreme levels. Microscopic droplets of engine oil mixed with raw fuel get trapped in the piston ring lands and spontaneously ignite before the spark plug even fires. This creates an uncoordinated, secondary explosion while the piston is still traveling upward on its compression stroke. The resulting pressure wave hits the rising piston with the force of a literal sledgehammer. The normal combustion pressure inside your cylinder sits around 1,000 pounds per square inch. An LSBI detonation spike can instantly blast past 3,000 pounds per square inch. I have seen the devastating reality of this factory shift strategy hundreds of times on my teardown table. Just last month, an owner towed in a 3-year-old Ford F-150 with the 2.7-liter EcoBoost engine, showing just 42,000 miles on the odometer. He was passing a commercial vehicle on a 2-lane highway, riding in top gear under heavy throttle, when he heard a metallic bang that sounded like a gunshot from under the hood, followed by a total loss of power and a cloud of white smoke. When I dropped the oil pan, chunked metal poured out onto the shop floor. Once I pulled the cylinder head, I could see that the number 3 piston had completely disintegrated. The hyper-elevated pressure spike from the LSPI event had shattered the piston crown, snapped the connecting rod like a brittle toothpick, and sent the broken metal punching a fist-sized exit hole straight through the side of the cast-iron engine block. The customer was facing an $8,000 engine replacement bill for a truck that wasn't even out of its powertrain warranty window, all because the factory computer prioritized a fractional fuel economy gain over structural mechanical integrity. The ultimate tragedy is that Ford knows this hidden vulnerability exists. To try and prevent these catastrophic failures without changing the fuel-saving gear ratios, they programmed a hidden protective strategy into the software called active knock retardation and enrichment. When the system detects the microscopic vibrations of an impending LSPI event via the knock sensors, it dumps excess raw gasoline into the cylinder to cool the combustion chamber down. Think about the absolute madness of that solution. To stop a destructive explosion, the factory logic floods your engine with excess fuel. That unburned gasoline doesn't just vanish. It washes down the cylinder walls, stripping away the critical oil film that protects your piston rings, and drains straight into your oil pan. This triggers the severe fuel dilution process we touched on earlier, thinning out your motor oil until it completely loses its shear strength. The factory settings trap you in a vicious, cyclical nightmare. The transmission tuning creates the extreme engine load. The safety system floods the oil with raw fuel to stop an explosion. And the thinned-out oil accelerates the mechanical wear on your bearings and timing chains until the entire powertrain suffers a catastrophic stroke. You cannot rely on the default factory setup to keep this mechanical disaster from unfolding under your hood. The fix requires you to take conscious, proactive control over how your powertrain manages its gear selection and engine load. If your Ford is equipped with a select-shift transmission, you must utilize the manual toggle switches on your shifter to force a downshift before you tip deep into the throttle, bringing the engine speed safely up past 2,000 RPMs, where the cylinder pressures naturally equalize. Alternatively, making it a strict habit to engage sport mode every single time you start the vehicle alters the shift mapping entirely, instructing the computer to hold on to lower gears longer and keeping the engine completely out of the LSBI danger zone. Ford left these options open to the driver, but they buried the risk factors in technical service bulletins that the average vehicle owner will never see until their truck is riding on the back of a flatbed tow truck. The deeper we dive into these hidden operations, the clearer it becomes that the factory configurations are engineered to satisfy regulatory compliance parameters and corporate cost of ownership metrics, not to ensure your vehicle survives past the length of its factory warranty. The mechanical stress building inside your powertrain right now is completely hidden beneath smooth digital displays and insulated cabin engineering, masking the structural degradation taking place every single mile you drive. We are far from finished uncovering the hidden traps Ford left inside your vehicle's baseline programming. There are still deeply integrated electronic parameters and mechanical blind spots affecting your braking stability, turbo cooling cycles, and steering geometry that must be dismantled if you intend to keep your vehicle out of my service bay. We have already pulled back the curtain on how the factory auto start-stop programming scrubs your crankshaft bearings raw, and how the aggressive transmission short shifting traps your engine in the piston-shattering nightmare of low-speed pre-ignition. Those two parameters are devastating to your core engine block, but they are driven by visible actions, an engine shutting off or a transmission lagging in a high gear. This third and final hidden setting is the most deceptive one Ford built into your vehicle, because it takes place entirely in total silence after you have turned off the key, walked away, and think your vehicle is safely resting in your driveway. If your Ford is equipped with a modern EcoBoost engine, there is a hidden cooling logic setting regarding the electric auxiliary coolant pump and turbocharger thermal management that is actively cooking your turbocharger center bearings to dust every single time you park. To fully comprehend the destructive nature of this hidden setting, you have to understand the extreme thermal physics of a modern turbocharger. Your turbocharger relies on the engine's exhaust gases to spin an impeller wheel up to speeds exceeding 150,000 revolutions per minute. Because it is driven directly by searing exhaust gases, the turbine housing routinely reaches temperatures between 1200 and 1500 degrees Fahrenheit. To keep the internal shaft from melting under this intense heat, Ford routes engine oil and engine coolant through the turbocharger's center housing rotating assembly. As long as the engine is running, a constant mechanical flow of oil and coolant carries that destructive heat away from the delicate metal journals. The critical engineering failure occurs the exact second you push the engine stop button. On older traditional turbocharged vehicles, drivers knew they had to let the engine idle for several minutes after a hard drive to let the turbos cool down. To eliminate this inconvenience for modern consumers, Ford installed an electric auxiliary coolant pump designed to run after the engine shuts off, using a process called thermal siphoning to keep coolant moving through the hot turbocharger until temperatures drop to a safe level. However, to preserve battery life and meet strict factory parasitic electrical draw limits, Ford's factory software configuration restricts the operational window of this auxiliary pump. The computer relies on a highly optimistic calculation rather than active temperature monitoring. If you have been driving on the highway, hauling a load, or even just climbing a steep hill, and you pull into a parking spot and immediately shut the vehicle off, the factory setting commands that auxiliary pump to shut down far too early. The mechanical consequences of this premature shutdown are immediate and catastrophic. The second the coolant pump deactivates, the fluid stops moving and instantly begins to boil inside the turbocharger housing, with no oil pressure and no coolant flow to dissipate the massive thermal mass trapped in the exhaust manifold. A phenomenon known as heat soak occurs. The temperature inside the turbo housing spikes violently, climbing well past the breakdown threshold of your motor oil. The stagnant oil trapped inside the turbocharger bearings literally cooks, turning into hard, abrasive black carbon deposits known as oil coking. I have torn down countless EcoBoost turbochargers in my shop that suffered from this exact factory-induced neglect. When you split the center cartridge open, the oil passages are completely choked with what looks like black charcoal or coffee grounds. This hard carbon acts like an abrasive sandpaper against the precision bearings. The next time you start the vehicle and drive away, those razor-sharp carbon particles score the shaft, destroy the oil seals, and introduce massive shaft play. Within a few thousand miles, the compressor wheel begins contacting the outer housing, spinning itself into metal shrapnel that gets sucked directly into your engine's intake tract. You are left with a smoking tailpipe, a completely blown turbocharger, and a $3,000 repair bill, all because a hidden software timer refused to run an electric pump for 3 minutes longer to bypass this thermal death sentence. You must implement a simple mechanical habit that completely overrides the factory software's shortfalls. Never shut your turbocharged Ford down immediately after a high-speed drive, a long hill climb, or a towing session. When you arrive at your destination, place the vehicle in park and let the engine idle completely undisturbed for 2 to 3 minutes before turning off the ignition. This allows the engine's mechanical oil pump and main water pump to circulate high volumes of fresh fluid through the turbocharger while the exhaust gas temperatures are rapidly dropping, safely shedding the thermal load before the vehicle enters its silent, unmonitored shutdown state. When you synthesize all three of these hidden factory settings, the bearing wear from auto start-stop, the cylinder destruction from eco shift mapping, and the turbo coking from premature cooling termination, a clear and alarming picture emerges. Your vehicle has been programmed by the factory to prioritize laboratory testing metrics over long-term mechanical survival. If you leave these parameters at their default baselines and drive your vehicle exactly how the dealership delivery specialist told you to, you are actively participating in the slow, systematic destruction of your own powertrain. Preventing these catastrophic failures doesn't require a master technician's license. It requires a unified proactive ownership strategy that counters the manufacturer's omissions. First, develop the immediate muscle memory to deactivate the auto start-stop system and engage sport mode, or utilize your select shift controls the moment your seatbelt clicks, keeping your oil pressure high and your engine completely out of the low RPM lugging zone. Second, completely disregard the digital oil life percentage monitor on your dashboard and commit to a strict 5,000-mile fluid exchange interval using premium full synthetic oil to combat the invisible threat of fuel dilution. Finally, give your turbochargers the thermal respect they demand by allowing the engine to idle and stabilize its temperatures before you ever touch that stop button. You already paid for the advanced engineering built into your Ford. Now it is up to you to manage that hardware with the insider knowledge that protects it from its own programming. Stop letting the factory default settings dictate the ultimate lifespan of your vehicle. If you want to continue exposing the hidden mechanical dangers that manufacturers hide in plain sight, and you want the unvarnished, shop floor truth on how to keep your vehicle running past 200,000 miles, hit the like button.